Hello there and welcome to Lower 6 Further Maths A-Level Pure Core Past Paper June 2013. Here we're looking at question 6. It's a new topic to Pure Core 1, so I've added this question in myself. The question is, shade that on the Argand diagram the region satisfied by... Okay, now don't be too confused by these squiggly brackets. All it means is the modulus for my complex number has to be less than 3. So that's the important part there, and the argument, once I've subtracted 3 from my complex number, has to be in between pi by 4 up to pi. So all these bits at the front here mean is that z is a complex number. You're working on an Argand diagram, so of course z is going to be a complex number. You don't really need to consider that part of it. Don't be too scared. This is your important part and this bit is your important part. So let's make sure our diagram is really super clear for this sort of question here. Please ignore that squiggly line. Try and make yours as straight as possible. In fact, even using a ruler would be best. Okay, so the modulus of z is going to be less than 3 in my first part. Now for this here, that means the distance of any coordinate must be less than 3 in my Argand diagram. So what this is going to form initially is a circle of radius 3. So 3 here, minus 3 here, and minus 3 here. Next, so for the modulus to be less than 3, it's going to be anywhere inside this circle. So I'll just remember that. Maybe I'll even make a note on the side. It's inside the circle. The next part of the question looks for me to draw a part of the circle where the argument, once I have translated my complex number, and in this case here, I'm going to be right by 3. Remember, in graph transformations it's always the opposite, so it's going to be left by 3. So my complex number is going to be starting at minus 3. It's going to have an argument in between pi and pi by 4. Now let's start with pi, the easier one probably. Pi is going to be an argument in between here. This is where pi is. And pi by 4 is exactly 45 degrees, which will make it have a gradient of 1. So for the angle of pi by 4, it's going to exactly go through my coordinate of 3 up at the top here. And it needs to be anywhere in this region from pi to pi by 4. So, given that we're looking for the union of these two areas, I'm looking for any area that is inside my circle and has an argument around from pi by 4 to pi. The only area that satisfies both of those inequalities is this area here. That's the area you're looking for this question. Easy, 6 marks.